Okay, let's talk about the unit circle. All right, here I've got like just a reasonably pretty circle. It's not perfect. Okay, I'm not perfect, but now we look at this horrific interpretation of the unit circle, filled with all kinds of blanks that you're going to be expected to fill in. So let's just relax for a second. Let's go back to a safe place. Blank circle. Okay, now the unit circle, the most important thing about the unit circle, really the end all and be all of the unit circle, is that the reason that we call it the unit circle is that it has a radius of 1. All right, and that's going to be the key to everything that we do. So when we impose or superimpose the circle on top of the xy axis, okay, so there's x and there's y. When we bear in mind that the radius is 1, which means that this distance is 1 right here, then some parts of the unit circle become pretty easy to understand where they come from. We're going to talk about the points on the unit circle right here. So these points and these over here, they get a little more complicated. But the ones where the circle intersects the x or y axis are simple. And here's why. Well, if the unit circle has a radius of 1, then the distance from the center to the outside of the circle is 1, and we moved up and down 0. So this point is 1, 0. And all the way around, this is 0 left and right, but 1 up. This is -1 to the left and 0 up and down. And down here we have 0 up left and right and -1 down. Okay, so the quadrant angles here, this is 0 degrees, 90 degrees, 180 degrees, and 270 degrees. The corresponding points that they have on the unit circle are easy to remember. So what I'm going to talk to you about is the first quadrant. You only need to know the first quadrant. Once you know the points on the first quadrant, you can use the idea of reflections across the y-axis, across the x-axis, and across a point, the origin, to find the other points, the other coordinate pairs. So really, with the unit circle, you only need to know the points in the first quadrant, and then you can translate the rest using reflections. So you need to understand that this point on the unit circle and this point are all related to special right triangles. A 30-degree special right triangle, a 45-degree special right triangle, and a 60-degree special right triangle. So the 30 and the 60 are the same thing, they're just flipped. So let's look at those triangles. We'll start with the 30-degree. Okay, so a 30-degree special right triangle is a 30, 60, 90, but the 30-degree is going to be the angle that the x-axis makes with the terminal side, which is the radius of the circle, which is 1. So there should be a number 1 here. But what do we know about 30, 60, 90 special right triangles? We know that the short leg, the one that's across from the 30-degree angle, is 1. The long leg, the one that's across from the 60-degree angle, is the square root of 3. And the hypotenuse, the one that's across from the right angle, is 2. Okay, so when we look back, where'd it go? Oh, when we look back here, the right angle is facing the hypotenuse, and the hypotenuse is the radius. Well, the radius of the unit circle is 1. And here we have that the radius of this right triangle is 2, or not the radius, the hypotenuse is 2. Well, we can't have it be 2, it needs to be 1. So the way that we make it 1 is we divide everything by 2. So we're shrinking the triangle down. It will be a similar triangle. It will have the same proportions, so the angles won't change, but the sides will change. We change them all the same way. So now 2 divided by 2, that's 1. And 1 divided by 2 is 1/2. And square root of 3 divided by 2, well, we'll just leave that as square root of 3 divided by 2. So if we go back to this triangle, we now have a hypotenuse of 1. The short leg is 1/2. And the long leg is square root of 3/2. All right, so how do we use this information to give us the point? Well, think about it. Our x value would be the distance we traveled from the center, the origin, okay? That's where we are right here. Remember, this is x and y. All right, we're on the coordinate plane. So the distance from the origin out is square root of 3 over 2 for x. And the distance from the origin up is 1/2. Like from the origin up, we go 1/2 to get to this point. So the corresponding point on the unit circle is square root of 3 over 2, comma, 1/2. Let's do the same thing with 45 degree. Okay, so here's a 45-degree special right triangle. And remember, on the unit circle, this radius has to be 1. Well, what do we know about 45, 45, 90 triangles? We know that their legs are 1 and that the radius is square root of 2, okay? Well, on a unit circle, the radius, or the hypotenuse, is going to be this distance right here, and it has to be equal to 1. Well, the way that we make it equal to 1 is we divide everything by square root of 2. Well, square root of 2 divided by square root of 2, that's 1. That's beautiful. But over here, 1 divided by square root of 2, this needs to be rationalized. So we'll multiply top and bottom by square root of 2. And what we get is square root of 2 over 2. It happens in both of these. I'll write this one out. So this will be, we'll multiply times square root of 2. And what you get is square root of 2 over 2. Okay? All right, so now looking back, right here, we're talking about, remember, an x and y. This is the y, and this is the x. And this distance now, from the center to the outside of the circle, the radius is 1, just like we want. In order to make that happen, we had to divide everything by square root of 2, which makes this distance square root of 2 over 2, and it makes this distance square root of 2 over 2. So the x, to get to this point, the distance traveled across the x-axis is square root of 2 over 2, and to get to the y component of the point on the circle, you would have had to travel up square root of 2 over 2. And there is our corresponding point on the unit circle with 45 degrees. Last one. So this is going to be a repeat of the 30, 60, 90 triangle. It's just that we've kind of shifted the way the 30, 60, 90 triangle is drawn on the unit circle. Remember that we're talking about x and y here. We're still superimposed on top of the coordinate plane. So what do we know about the 30, 60, 90 triangle? Well, we already did it once. We know that the short leg is 1, the long leg is square root of 3, and that the hypotenuse is 2. Well, the hypotenuse, the radius of the circle, is going to have to be 1. So we'll repeat the same process. Well, 2 divided by 2, that's 1. It's beautiful. Square root of 3 divided by 2, we'll just leave it as is. And 1 divided by 2 is 1/2. So going back now, in order for us to have a radius of 1, we divided everything by 2. The long leg is now here. That's square root of 3 over 2. And the short leg is now on the x component. So that's 1/2. So the point that corresponds with 60 degrees is 1/2 for x and square root of 3 over 2 for y. Then we take all this and put it together. Like I said, we'll only focus on this first quadrant for now. But it's easy to see now that here we have square root of 3 over 2 over 1/2. Here is square root of 2 over 2, comma, square root of 2 over 2. And here we have 1/2 over square root of 3 over 2. That's where these points come from. If we're reflecting over the x-axis, the y value will be negative and the x value will stay the same. If we reflect over the y-axis, the x values will be negative and the y values will stay the same. And if we reflect across the origin, then both values will be negative. the x value will be negative and the y value will be negative. The unit circle, points, no problem.